he like rewrote all of the reward stuff.
Sure.
So we had a reward in your time for ticket. I didn't know. Like, we had all of them.
Yes, the conversation of that.
Yeah, maybe everyone on the computer should.
Sorry, yeah.
It's gonna take so long. It's like,
That makes sense.
basically like
In the middle.
All right, everyone ready? Everyone enjoyed the pizza? Okay. So, hi everyone, welcome to today's, this month's edition of the Android Plus Meetup Group. I'm your host, Jimmy, along with your co-host, Naveed, in the back. So today we have our, from Capital One, Dustin Summers. He'll be speaking about Android security, specifically about obfuscation. And I guess before we get started, I have a couple of notes. Let's see. So first of all, thanks to Capital One for providing the space and the food. If anyone needs to use the restroom, they're just across the hall. If you parked in the parking garage and have a ticket, I'll be happy to validate that for you, so you shouldn't have to pay when you get out of the garage. Next month in August, on August 14th and 15th, we have our Android Summit at nearby in McLean.
It's the tall building, tall glass building. Part of it.
Tall glass building that you can see when you're on 495. I believe we are hiring.
Yeah.
So let me know if anyone's interested in a new opportunity with Android or
Any role.
or yeah, in any position with many technologies. Let's see. Is there any other?
It's the iOS dev camp pool.
That's next month too. If anyone's interested in iOS development as well, there is a iOS a dev camp DC also next month. So feel free to check that out as well. I think that's it.
Yeah, that's it.
Okay, so without further ado, Dustin.
All right, everyone. Thank you for coming out. So before we do introduction and what I'm actually going to talk about, we're going to run some commands real quick, if you have a laptop. So this is just, if you already have Android Studio installed, this is just setting your Android home, your path to your SDK. So if you're good there. We're also going to clone in some typo tools. This is going to help us with compiling using D8 and R8. So you should see this output. It'll only take a couple minutes. And I will provide all these slides for those who are not able to participate, so that you can do this in your own time if you want to go back through. All right, next, basically just set up your path variable to point to that folder that you just installed. And if you're using fish, it's a different thing. Sorry. All right, now we're going to actually git clone the R8 source. And I will be explaining all of these things as we go. I just wanted to make sure kind of getting these out of the way. Everyone good to go? I'm not sure how we check. So you should be getting this command once you're cloning into that. Feeding into that folder, because we're actually going to be launching something from there. Way down at the bottom, and then set R8 home variable to your current path. I'll slow down a little bit, but and then basically what we're going to do is launch Gradle.py to build D8 and R8. And this is going to take a while. It took about 5 minutes on one laptop and about 2 minutes on my home computer. So depending on how long that takes for you, I'm going to go ahead and move on. But is everyone caught up at least to this point? Mostly just downloading a couple things, setting up some path variables, and then getting D8 R8 installed. Seems like I'm getting some nods of approval. So, and we can come back to this PowerPoint. All right, so obfuscation fundamentals. My name is Dustin Summers. I work here at Capital One. I've been here for about 6 months. I'm a security engineer here, working towards the security of our mobile banking application. I would say we could go around the room, but that's kind of what the networking portion after this is going to be about. So we can catch up on each other's backstories then. So one thing of note, naming is difficult. So I do say obfuscation the fundamentals because I look at obfuscation not as just like adding some keep rules in a ProGuard file, but really it's the entire there is a Stack Overflow answer of like what keep rule do I need for this ProGuard rule or to stop these crashes from occurring. There's also like all the compilation that goes into actually getting that DEX file. So from source to the DEX that's going into the APK, how are we getting there? What is involved with that process? So that's kind of what this talk is going to be about. So we're going to go through very simple examples of Java compilation using DX to turn that into a DEX file. How multiple classes from Java compilation are going into one DEX and what that looks like. We're going to move on to some of the more advanced Java 8 features and what happened with the compiler during that time. So like introducing lambdas, compiling with D8, and some of the unique functionality that like D8 and tools like that do without ProGuard or R8 being in the picture with their shrinking and optimization. So D8 is already able to dedupe some of your method references. So giving examples of that. And then we'll actually be compiling with R8, looking at APKs and their source code to kind of, see, so you can see actually what's going inside of the APK and, how these steps all play a part into getting there. So did everyone get a build success? This is just me just checking, making sure. Okay. Sounds like it. So I'm only pointing this out. It took like 2 hours for me to download it, so this isn't going to happen here. But there is tools test.py. It's actually really cool, and it's something that I want to dig into more, but this will allow you to test. R8 has a built-in ART VM that you can test your DEX files inside of using this test.py suite. So it's something that I wanted to look into a little bit more, but if you're interested after this, feel free, but there is that file in their tools test.py. And on R8's homepage, you can actually read up more on that. Seems pretty cool. All right, so goals. Comfortable reading Dalvik, Smalley, comfortable actually looking inside of the classes.dex and semi-knowing what you're looking for. It is still confusing, but, just this course has kind of helped you gain a little bit more comfort, kind of understand or explain a little bit of what's happening there. Understand the Android compilation, how it plays in obfuscation, I mentioned that, and then the stages that transform source code to bytecode. So, I know a lot of us as Android developers, we just hit the play button and hope something good happens, and that we get that build success. But this is actually going to be talking a little bit about what's going on, in between there. So what this course will not teach, so I'm not going to go into all of the key tools. I am going to mention them and like which ones you should be using and should not be using. But I do want to have a follow-on lesson of like exactly what those key pools are doing for you and for your bytecode, so that it's a little bit that there's more concrete examples, because a lot of the examples out there, they don't really show the bytecode of what the key pools are doing for you. And this, I'm not going to teach about a hack. So this is definitely a way to hack, modifying DEX files. And if you want to see how to hack, please join myself and Dan Lowe at the Android Summit, where we will be going into how to do this next. So this is almost like a precursor to that, just understanding the DEX files. All right, so real quick, what's in an APK? You're all probably pretty familiar with this, but an APK, very similar to a jar, it's just a zipped up file format of a bunch of other files. You have your resources, you have your manifests. I'm not going to harp on this too much, but primarily what we're going to be looking at is this classes.dex. Sweet animation there. So why DEX and not just a class? This is a little bit of a history lesson, but you know how whenever you compile with Java, you get a bunch of different class files. All those are packaged up, go into a jar, and the jar can run inside of a VM and launch all those different class files and all that Java bytecode, and it's comfortable doing that because of modern computing power. So typical Java runs multiple class files. DEX came about because of the processing power of Android not being as strong as modern computing. So Dalvik VM was the original VMs that were installed onto an Android device. So DEX stands for Dalvik Executable. So essentially what DEX is doing is combining all those class files into one DEX file, so that it's easier for the VM, which used to be Dalvik, now it's ARC, which I'm sure some of you have heard, Android runtime. It's easier for that VM to parse and turn into machine code. So, yep, so there we go. Combine everything from all that class files into one DEX file. And that's, ideal. Really, you're probably going to have multiple DEX files. Even with my simple app that I'm going to show you all, I have like 7,000 method count, and your top method count is 64,000. And then you have to spill over to multi-DEX or multiple DEX files. The goal was to add one DEX file, but goals are cheap. So there you go. Or multiple if you hit the 64,000 method limit. And you have to use the multi-DEX. So one of the nifty things that DEX does is it just throws out all your architecture. It doesn't care about all that fancy stuff you added in your Java or Kotlin code. It doesn't care about your fancy async tasks or any of your fancy like how you're structuring your classes or anything like that. It's going to just make it as simple as possible for its own VM's purpose to execute. So duplicate strings and other constants, it's just going to add those into one so that all other methods or classes can reference that one constant variable instead of having to go to multiple places to access it. And that's to conserve space and just easier access on the on the runtime part. So here we go, compilation pipeline. So you got your source code. So actually, all right. So in a little bit, you're going to actually download my GitHub code, but in there you'll see some test files, and that's where our source code goes. We compile that with Java C or Kotlin C, which stands for Java compiler or Kotlin compiler. And then you get your bytecode. And this is Java bytecode, not DEX bytecode. So let me go ahead and actually let me see if So here we go. So if you are still in the R8 folder, go ahead and get out of that. Here is my GitHub link. So git clone github.com/summers obfuscation.git if you want to follow. CD into the test file 1, and I'm going to show you everyone here what is in the test file 1. So test file 1, super simple, hello world. Oh, that's not really nice. Super simple hello world example. Class test file 1, no longer compile now. The system.out line, nothing fancy going on there. All right, so we're going to compile that using Java C, and notice that we're targeting source 1.7. Source and target are both 1.7. That's Java 7. Test file 1.java, and I'll explain why we're doing that later. And then after you run that and you run ls, you'll see that your Java file is no class file. This is all hopefully you all have done this before. It's a good refresher. So in order to launch that file or that Java class, you just run Java test file 1, and there you go. Hello. So now you are all programmers. Try to make jokes, but not going to. All right. So we got our bytecode. That was easy enough, right? Java C, get that bad boy. So now we're going to DEX it, turn it into Dalvik bytecode using DX. And that will give us a classes.dex file, or if you can specify a different name of it. I think, which I do, I think I said test file 1. No. So yeah, if you want to DEX that bad boy, you just run DX, DEX verbose, test file 1 class. You'll get, there we go. Magic output. There you go, you will get processing, ls, and then you should see a test file 1.dex file appear. Now we can run dex dump, which will basically just dump everything that's in there, so it's a little bit more human readable. So So dex dump tacti, and you can also map this. I show how to map it here if you want to map your build tools so that it's a little easier to run dex dump in the future. Okay. So now I'm going to just show you what that looks like. It's pretty simple. All right, so at the top here is just our declaration of our class file. And then you can come down and you can actually see our main function, which is being called, our main method. And I don't like formatting this, but so you can see here this is inside of the main method. And again, I'll show you the actual source code. Here we go. And inside of the main method, we have a, looks like we're getting system.out method, getting the print string. We're passing in a constant string of hello, I'm compiled now. We're going to invoke that and call print line, and we're passing in those arguments. So we're passing the system.out and the constant string to print line, and that is our entire function. So during void, and that was it. So that is the dex that is generated from that tiny class. And this like small portion over here, it's how it's formatted is kind of messed up, but it's what you call smally. So there's other tools that can actually just strip out all this other garbage and package it up nice and neat for you. And just kind of show you this smally code over here, which is just the constant string declaration, getting an object, invoking that virtual method. So I'm just kind of showing you the nitty gritty without fancy tools how you can actually do this. All right, so that's mind blowing, right? Yes. All right, moving on. Test file 2. So this is
I think we got questions.
Oh yeah, crazy. What's up?
Yes, is this text file, is it Google named like that, or it has a different name if Google uses?
No, so it is named. Usually, like inside of your own application, it's going to be like classes.dex. But that is, it stands for .dex is Dalvik executable, and that was the VM that was originally inside of original Android phones, and that's what actually launched the .dex file. Not sure if that.
Okay, that's what
Okay. Yeah. Yeah. Any questions at all? Feel free to ask.
Why was it two parts? Why did you have to do from .java to .class?
Because there are just different stages. So we first have to turn it into the Java bytecode before we can run Dex on it to turn it into Dalvik bytecode. It's just, that is like our stages of compilation on Android.
Okay, so like probably Google just like took what was existing with the class and then did their own.
Exactly, right. It's to format it to run better on Android. It's, yeah, they're trying to take...
It's like a layer abstraction.
Exactly. Well, yeah, they're trying to take those, because if you, especially as Java classes grow, like you have a ton of class files, Google was trying to make it so like Android wouldn't have to hop around to all these different class files to find, which method it needed reference, because, on an Android phone, especially back in the day, the thing was built to be a camera originally, so that, they weren't the most like powerhouse machines. So putting them all into one file just makes it easier for the machine code to actually be able to parse and go through, instead of having to hop around to a lot of different classes to do the same thing. So that's why we use Dex.
And then the second question is that this is, so basically the entire app becomes this format, and how does this format know, so this is basically, you can read it and actually reverse engineer it to Java and or like.
Yes and no, there are tools that can do that. It's more you can understand the logic flow of an application from this code. Sorry, I'm not sure if I'm...
So Dex is almost like an APK file? Like you could run the whole app if you have the Dex?
Yeah. I mean, if you can repackage it up, if you have the Dex and you have all the resources that it accesses and things like that, yeah. Because that's one thing that I'm going to show you later on is like how we can actually take an APK and crack it open and look at everything inside of that as well. And you'll see that the classes.dex file is sitting inside of it. I mean, you can't just have a dex file and run an APK on an app. You'll need some other things there, but it's not outside of the realm of possibility. You just provide it like a manifest file and some other things like that. So,
So it's basically a water jar file for Android.
exactly. Yep. Yep.
That's my question, so I'm kind of confused between the difference between the APK and the next.
So an APK is the actual Android package. That's what's, so think of an APK like you think of a jar. So that's where, that's what holds everything that will encompass your application. That's what an APK is for Android. And the source code inside of the jar is all of those .classes files. The source code inside of an APK is the .dex file, or the classes.dex file.
And that's what actually gets run.
Mm-hmm. Yep. And it's run on, these days, it's called the Android Runtime VM, so ART. It used to be Dalvik. Yeah. And so that's like, just like Java, how it's run in like its own little container, the JVM, that's what the ART is for Android. So each app is kind of running its own little self-contained virtual machine.
When did they stop using Delta?
I think that was around, I want to say KitKat, but I'm not 100% sure. Yeah. All right, good questions. Any more? All right. So this next exercise is just to kind of show you how multiple classes actually do get combined into one dex. So we're going to walk through the same steps. Let me go ahead and show you real quick those files. So this is test file 2. So we have an interface, postman. This is all just a very elaborate, basically way to send a message. So these are trivial examples for a reason. But we have our interface, postman. We have our static class that's going to implement that interface. And it's going to call into that interface's method and send out the system.out line. We have main, which is going to pass in the messenger object, which is this message down here, which is just basically a wraparound string. All right, so I'll make sure to leave that up. And there's your typical set message, get message in there as well. All right, so going through, go ahead and compile it, targeting 1.7 again. And this is what we will get from the Java compiler, turning that into Java-like. So you can see we have a message.class, which is that message object. We have the messenger class, which implemented the interface. So here's our interface. And we have the overall class, that's file 2. So this is what you would see if you cracked open a jar and were to look inside of it. These are the classes that you would see there. Not index. So this is me running that file. So Java test file 2 launches all those classes. And here we go, send a message and implementing interfaces. All right, so now we're going to dex it. And you can just do a wildcard here of star.class, and that will grab everything. And there you go. So it's saying that it's processing everything.
What's that -dex parameter?
I think that's actually what it's calling out to turn it into a dex file. I'm not sure what other options are there.
So the dx doesn't cut it.
No, that's just like the actual jar file to launch it. Yeah, I'm not sure what other arguments dx has. Question though. No, I won't do it. All right, so we ls, and boom. So now we have our classes.dex file, which contains everything. We're going to do the same thing, dex dump it. And ignore the 0. Not sure that's there. There should just be dex dump type in the classes.dex. All right, so there's what you get. Okay, we're good? Can you read that? That's right. All right. So here we go. So this is the dex file. So first class we got here is our message, which again, we were just declaring it as a string. Or a string was being passed in the constructor to build it because it's basically just a big wrap around the string. Here's our get message and set message. methods that are in there. You can kind of see what those bad boys are doing. We're returning the object of our string field. We have our interface, and of note, that $sign. So it's saying that inside of test file 2, there is this other class. So this is definitely important for whenever you get into obfuscation. Inner classes are always referenced with a $sign. So this means that inside of test file 2, there is another class or interface. And this one actually does call out that it is an interface. There we go. This actually calls out that this is an interface. And this is just setting up its default message. Sorry, I'm just trying to, I don't want to waste too much time looking over these. But this is just to kind of show you that, that all of those class files were put into this one dex. So it makes it easier on Android.
So do Java 8 plus lambdas also look like inner classes when they're in this form?
Whoa, sir. Whoa.
Sorry.
Are you reading ahead?
Yeah, sorry.
we're definitely going to get to that.
My bad.
Yeah. Spilling beans, so that was supposed to be an exciting moment for everyone. That's okay. All right. So, any questions on that file of putting?
There
Yeah.
are multiple interfaces there, you put multiple names there.
Yes. Yeah. So if you add, Postman 2, there would be another, $sign Postman 2 reference there as well. So. All right. So moving on to introducing lambdas, or if anyone has any questions about that. All right. So real quick, let's go over that file. So here we go, test file 3. Stupid me, I was like, gosh, that was some horrible naive code that I wrote. Like I can accomplish everything basically, in 3 lines. So here we go, declaring our same interface Postman, our same letter time, initializing, and using it as a lambda. So there's our message argument, and this is what we're going to do to it. Just let out that print line message. And here we go, calling that method and passing in our string. It's a new message, I'm using lambdas. All right, so same thing, compile. Notice here that we just have the Postman interface. Run it, just leave a message. Exit. Oh, real quick, notice that I did not include the source or target for 1.7 because, well, yeah, we'll get into that. And boom, here we go. DX was not able to actually parse our file, and it was, as he mentioned, because of lambdas. Lambdas are a 1.8 feature. DX was unable to process lambdas at the time, so inside of that Java bytecode, it sees that lambda and it just kind of throws up, doesn't know what to do. You can, as it's saying over there, it requires a min SDK greater than 26. So this was around the time, I'm actually going to have some slides on this. So yeah, what happened? So, our previous processes were not working. So up until this point, things have changed after this point. We still have our source compiled, but what happens inside of the Java compiler was that they had a transformer in there that desugarized, or that should have desugared the Java 8 bytecode to be readable by Java 6. And that's all desugar means, is it basically makes advanced features of Java or even Kotlin these days readable by like the lowest level possible. So it tries to convert like lambdas and other features, newer features like that, into something that is going to be readable by an Android 1.0 device, essentially, or anything that's running Java 6. So if I were to compile with source 1.7 and targeting Java 7, this is the error that we would have got, that we would have needed to use source 8 or higher. So that's why I didn't want to run that, or else you all would have seen. But yeah, so it says use source 8 or higher to enable lambda expressions. And don't worry, I'm going to show you all this like what everything looks like under the hood as well. So this is, current process didn't work. So what happened? Like what did Google do to account for this or to upgrade Android to be able to utilize Lambdas? So back in the day, they actually used to have to use something called retro Lambda, which was an entire library that just let you write Lambdas. So this was nice that Google brought it as a first-class library so that everyone could use it. So essentially what happened was that they took that desugaring phase, which breaks down the Java bytecode to be more readable, and they actually put it into a new compiler called D8. So D8 does your desugaring, but it does it at the DEX level, not at the transforming level. So it's not worried about the whatever the Java bytecode is producing. It's worried about what the DEX bytecode is producing. Because at the end of the day, we want better Android bytecode, not better Java bytecode.
What is these?
I don't know why they call it desugar. I guess because they consider like all the new features that Java is adding as sugar, and so they're desugaring it. But what it is it's just taking. So I am going to show inside of like the bytecode like what's actually happening, but it's essentially just letting things like lambdas be readable to something that has no idea what lambdas are. So Java 6 it did not support lambdas, or Java 7. So desugaring allows, if you do have lambdas, for those other source, for like Java 7 or 6 to be able to actually read and execute that. So it does produce more bytecode under the hood, but it allows developers to take advantage of those newer features. And that's still very prevalent today, and that's why I bring this up. I know this isn't necessarily obfuscation, but it is a lot of things that are happening under the hood prior to obfuscation even being able to take place. So, if you're looking at your code, like I never did this, like I don't even know what this bytecode is. It's because desugaring probably took place and produced some things that you weren't expecting. So, yeah, test file 3. We're still looking at that same file, but now we are going to compile it with D8. So here's the command for that: java tech jar, going into your R8 home, and there's d8.jar in there. You point at your Android 29 or whatever version you have for the different libraries it needs, and yes, so you want to run it. So ls, and that will produce the classes.dex file. We're going to do the same thing. Go ahead and dex dump that in the test file too. All right. So I just, instead of pulling up, I will pull it up inside of Sublime, but this is just kind of a quick highlight. So what you can see here is that here's our main method, and inside of that, here's our lambda. So all lambdas are going to be prefaced with this $, lambda, $, and what's weird is that this is essentially, they created a class file for us inside of the DEX file. So this is like a class file that we didn't even write, but they went ahead and added it for us. And then it's a static class, so we are getting an instance of that and assigning it. We're getting constant string, so yeah. And then down here, our lambda main 0, this is actually just a method that DEX also created because we were passing that system.out print line into our lambda. So this is actually just saying, oh no, this is actually just a method inside of test file 3. It's not being passed anywhere. And inside of that is just our system.out print string print line statement. And then this is just kind of declaring that lambda class. So it's just creating a new instance of it, and initializing it. And then this is just us calling the letter time on that lambda. So I know it's a lot to take in, but this is essentially what happens. Whenever you use that little bit of code, it turns into quite a bit of work underneath the hood to account for you using lambda. But I hope that answers your question.
So the double dollar sign.
Yeah,
What's up? That's just representing like lambdas, I guess, or
I think it represents me. I'm not 100% sure, so don't take what I say here with a grain of salt. But I think like anytime desugaring takes place, I guarantee that they probably put some kind of title like that in front of it, like lambda or companion object or something like that, to account for that this was a new object that was created or a new class that was created for us to deshow or to be able to process it. Yeah, I'm not 100% sure on that though. All right, so I'm going to actually show you just what that looks like, because notice here that I did put like a 1 here. That's actually not what it looks like. There's actually a giant hash that accompanies all of those. And I'll explain why in a bit. But so here's actually that bytecode. So you can see lambda main, the system node out, parent line. Here's our interface. Yeah, so here's that hash I was just talking about. Like I said, I will discuss what that is all about. Yeah, so this is all the bytecode that was generated for that lambda. And, sorry, I was supposed to walk through it like this. All right, so yeah, so the instance fields, so that lambda body that we saw, it contained a hash. So what that essentially means is that, say you had multiple lambdas that you were generating, just line after line, and I am going to show that here. The hash is actually a representation of like what is all going into that lambda, so it includes like line numbers and the text in there, so that way if you are trying to debug your application, it knows where to look for that specific lambda, so it won't get lost. And also D8 can deduplicate method references, so I'm actually about to show you that now. And so this will save on an overall method count of, that 64,000 method count limit that Android puts on us, unless we want to do a multi-dex. So I will show you that now. So that's test file 4. We're going to go ahead and move into that. So essentially the same thing. We have our interface, Postman, and we have this new method down here, send message, which is just going to take that interface as an argument and call its method on there. And we're calling send message and invoking it as a lambda. So, and these two are the method references I was mentioning. So you can just call send message, system.out, ::print line. And so the actual bytecode for that, so real quick, here's the output. My fancy message, second fancy message, and the 2 defaults at the end there. So go ahead and run that through D8 dex dump, and here we go. So this first part, you can see this is similar to what we just looked at, where it's declaring that lambda as its own class, pulling in an instance. And this number 1, imagine that's that big long hash I just showed you. Same for number 2, exact same thing, but a hash would change. I just represent it here as a 2. But then for our method references, for our lambda references, this is actually just, we're getting the print stream object. We are getting an instance of a lambda, but see here, the hash is 3. And then we're just, it's like we're just calling that send message, and inside of that is actually the system.out line. And then same thing down here, it's the exact same call. So this is basically just 2 duplicated things inside of the dex, but it's not having to generate a new lambda. So it's kind of a nifty feature. And so you can take advantage of this in other ways. You can pass arguments to a method reference. So, so that way, if you're doing a lot of lambda references or method references and passing arguments to it, you can save on your overall method count. So here is just kind of real quick some of the bytecode that accompanies that. We have our interface, and that's mostly wanted to show you all the hash that's happening here. So here's our first hash. Repeated. The second hash. Really hard to read this one. Yeah, I would just say actually look at this one at home. It's kind of hard to read up here. All right. So now we're going to move on into obfuscation and action, and actually opening up some Android files and kind of looking at the DEX files inside of those so that you can see what's happening. And I'm building on top of the files that we were just looking at, so that should all be pretty easy for you all to see. But I do want to kind of give a quick overview of ProGuard versus R8. So R8 is fairly new. ProGuard's been around for a while. ProGuard's been around, I don't know, I think since, I want to say since the beginning of Android, but don't quote me on that. And both of these they're not just obfuscation tools, which is what a lot of people think about for ProGuard. It's actually, it does optimization, it does shrinking, and it does obfuscation. So what that means, let me actually start going through this. So for ProGuard, you have your source code, you compile it with Java, and then at the transforming stage, so before it spits out a .class file, ProGuard comes in and it tries to optimize that bytecode. So it does shrinking, so essentially anything that's unused or dead code, well, not really dead code, but anything that's unused inside of your apps, so resources, streams, whatever, it can see that and get rid of it. Optimization is very similar, but it can find things like dead code paths, or it'll inline resources for you, so it doesn't have to go somewhere to access those. It can just put those in place. And then finally, it does obfuscation, which that's essentially, it does name obfuscation, so it'll rename everything in your path or in your DEX file. So essentially, what this means is that I think they look at it more as a way to shrink the code even more, instead of having these big long class names like that lambda, $sign name, $sign whatever. They can just reference that as A. So it shrinks the bytecode just that little bit more, but it does add a layer of protection there, because it is more difficult to trace and see what's going on, as I'm going to show here in a minute. So ProGuard happens at the transforming stage, so it's doing that on the Java bytecode, and then it gets the class file. And then it kind of pumps that over to D8, and D8 does its dexing and turns that into your DEX file. So again, we've used ProGuard forever, but just literally this Android Gradle plugin update, the new default for your Dexer is R8. And so I'm going to explain what that means. So here we go. So at the transforming stage, we're no longer doing anything. Unless you have like custom transformers, but we no longer really care about the Java bytecode that's being produced there at that class stage. So we get our class file, and then that is punted over to R8. So now R8 is the new. I wouldn't say it's actually more of just like it's another option for D8, but they call it R8. But it's essentially using a lot of the same things under the hood. But R8 also does the shrinking, obfuscation, and optimization that ProGuard was doing at the transforming stage. But now, we're actually doing it at the DEX compiling stage. So this is pretty awesome because, at the end of the day, we don't care about how good our Java class or our Java bytecode is. We care about how good our DEX or Java bytecode is. So, with them looking at it at this stage, they can get a little bit more refined, as far as what the output's going to be. So that's, and R8 is produced, I guess, owned by Google, so hopefully they have a little bit more insight, and we're gonna protect it, or not really protect it, but I guess apply those modifications that are gonna be the best for our community. The reason these are still both very much in play today, though, is that, well, one, ProGuard, people have been using it forever, and I would say a lot of big corporations, they're not necessarily using the latest and greatest as it's coming out. I think as R8, especially being the default now inside of Android, the newest Android Gradle plugin, that it's going to quickly kind of start overtaking. But ProGuard, and the makers of it, Guard Square, they also produce another tool called DexGuard, which has a lot of other enhanced features on it. So like they have class encryption or stream encryption, code obfuscation that can add in a lot of dead code to throw off malicious people trying to break up your application. So so these it's nice because like they're going to be in play together for a while, I believe. And so it's going to be nice to kind of see what the battle that happens between the two of them. Yeah, I mean, especially if R8 starts doing things like class encryption, string encryption, that'll be interesting. And so what I'm going to be showing today is R8 because that is the latest and greatest, and here at Capital One, that's all we care about. All right. So valid with R8. So I'm going to go ahead. Pretty sure, yeah, it's probably. So open this bad boy up. So again, this is just things so you can see it. All right.
ID is
Stanford Studio. Yep. That's dark here, I think. So very, very simple. Essentially doing what we were just doing with that last file. We have a couple lambdas. And we're using this, because I don't think anyone uses system.out line on Android, or you shouldn't be. So we're using log here. And essentially doing the exact same thing. We have our interface postman calling log time, taking in arguments, tagging a message. We have our method here, send message, and producing that default log, and then, yeah. So relatively easy, very, very simple, as you can see. Not a lot going on, single activity. All right, for our ProGuard rules, I just have one, and that's going to obfuscate. I just want to show you what it looks like first. And I do want to kind of quickly show you how I went ahead and did all this. So inside of your build.gradle, in order to have ProGuard turned on, you need to have that minify enable turned on. And then I'm using a default ProGuard file, which is just to optimize it. And then setting up different flavors so that we can kind of easily produce and use whatever rules file that we want. So I'll be going through the rules files and the resulting bytecode at the end of each. All right, so for those of you who are aware, Android Studio has a really nifty feature where you can just simply drag and drop an APK to actually go to view its contents. So I'll demonstrate that here. So here's our APK, drag and drop. Oh gosh. Except whenever you're doing a demo. Yeah, that's a new feature. Right. Oh, I want to show you the drag and drop. Now I got this nice one. Just including that. That's nifty. All right. So here is our inside of our APK. So kind of going to your question earlier, like, what is an APK? It's very similar to a jar. I know you all cannot see this. Just command plus. Alright, so my Android Studio is not want to work perfect. So I'm going to go and restart my Android Studio. It's all part of the presentation. Take 5. What was the question again?
Why would you have to dump and look at the text file rather than what people?
So one of the reasons that I do it is for security reasons. So we like to look at our application in this level because that's what's going to be out there to everyone that has our application on their phone. So if we have any kind of sensitive areas, like for instance, if we're doing some kind of sensitive action that's pretty much in the clear that anyone that's plugged in or pulls in the APK can see by looking at the DEX file, that's the stuff that we want to cache and try to obfuscate or encrypt or just provide some security around. So that's my main reason for doing it. Malicious actors, they have other reasons, and they're it's pretty trivial to open up an APK in Android Studio or whatever and add in your own Smalley or DEX code into that, and then repackage it up, sign it, and then act like that's your application. And people, they can download that application, and you have your own malicious code in there, then you're pretty much on that app.
So are you gonna look at thousands of lines of code?
You don't really have to. Again, this wasn't a hacking course, but you don't really need to go through thousands of lines of code because the Android manifest will typically point you to where you need to go to start out, because that is where your launch activity will be, and it's pretty much in the clear for where that is. And so if you just go in there and you just kind of start stepping through and seeing what the application is doing, or reading via Dalvik and kind of tracing it out, you can kind of get a general understanding of what's happening. So let me get stuff back up. So it's still not necessarily letting me zoom in for some reason. Just cut this out to the side.
You should be able to use your main window, and if you like shrink that in Android Studio, you should be able to use that how we used to do this tax method. Go to the top, shrink that down. The rail sync fail just below that, there should be a bar for rail sync.
Yeah.
Just below that, there should be one of those should let you shrink that down.
It's mostly this window that I was trying to zoom in on. Anyway, so I guess we don't really need to do that. I just kind of wanted to show you how the application looks at this stage. Again, apologize for not being able to zoom in on this. But so you can kind of see this is actually specifically calling out our main activity here, and these are our lambdas, and then here's the method reference lambda, so it only has the one reference to it, whereas these other two, they have two of them. So that's kind of all I wanted to show with this little demo here. And now we're going to actually apply obfuscation so you can kind of see what that looks like. Okay, so this next file, as you can see, I essentially emptied it out. So this is still going to be applying that first default ProGuards rule that we pointed out. So this ProGuard Android optimized. And I know we're saying ProGuard here, it's actually still running R8 under the hood. They just still utilize the ProGuard files. So empty files, so this means that it will obfuscate our code. I'm still using the exact same one. So now we go to our classes.dex. Into that same folder. And I apologize again. You can kind of face for me. So I guess, you know, if you look at this at home, so what's actually happening here is that it obfuscated all the method names and all the lambdas and everything that we had. And what this actually shows is it just says A, C, AAD, A, B, C. So this is actually, or actually that last one is on create. So essentially it just turned everything into, you know, gibberish. So this is all that your attacker would see. So they wouldn't see that this was a lambda. They can still tell that it's accessing some kind of stream. And inside of the bytecode itself, you can still see, I know this is difficult in the back, but you can still see that these are, you know, static string variables for tester one, my new fancy log message. So that is all still being printed out.
So you're able to see what's inside there, right?
Mm-hmm.
So why would hacker also see those things what's inside? What determines that?
No, they would be able to. So the obfuscation at this stage for what ProGuard provides is really just name obfuscation. So it just kind of covers up what the method names are, what the class names are, but it's not actually going to hide any kind of constant strings that you have in there. So that is one of the difficult things with ProGuard is, so you do have a string that's called, you know, super secure password. If you can find that and say your strings file and then see where that's referenced in the code, you can actually see where that's being called at and what's calling that or where it's located, and that can kind of clue you in on what else, you know, where else you need to look. So that is, I guess, one of the obfuscation isn't like, you know, you put it on your app and you're good to go, like, you know, no one will ever be able to hack you. It's more just, it makes it less, or it makes it more difficult for it to happen. It kind of moves the fruit up higher on the tree, but it's still very possible.
What did you command you use to escape this code?
So this is just built in actually. So if you just, so I can actually zoom in on this folder, see, or this file. So here in your build types, so usually this would go into your release version of your application, but I put it into the debug here, just, you know, it's easier and I can actually debug it. But unified enable true, that's actually what will turn on ProGuard for you, and then referencing this ProGuard file is what will turn that on for you, so the obfuscation will take place. And these files are provided by ProGuard, and they're actually inside of the jar file that they provide, and you can go through those text files and see all the things that they're applying to the code.
You probably already said this, but what's to prevent someone from getting into the tool of deobfuscating? Is there some unique thing you're putting in there that secret key or something that makes it unique to me?
No. So with things like DexGuard, they have features that are kind of like that, but with default ProGuard or R8, no. It's just the name obfuscation is literally just like, I'm going to change this name. So instead of it saying cat or whatever, or, you know, send message, it says hey. But you can still trace where that method is being called. And that's not a, there's not like a super secret thing that's covering that up. I mean, you can just follow that reference chain and see what's happening with that. And so, you know, an attacker with enough time, they can figure out what's going on in your application.
But can you run the tool in reverse for deobfuscates?
Yes, there is actually a tool, and I can kind of show you here, but so essentially whenever you do apply obfuscation, a file is produced. It's actually called a mapping file, and that's actually what all your obfuscated code, like what's being changed. So in here you can see, so if I look up Postman, you can kind of see down here, Postman is A. My lambdas that I'm creating are like that Postman interface is the CAAD. So you can kind of, this is what you would use to kind of map back and see what that obfuscated code is from a developer perspective. You definitely don't want this to get into an attacker's hands.
Okay, so attacker doesn't have access to that file, therefore he cannot deobfuscate.
They would be able to deobfuscate it in this manner, but looking at it and figuring out, you know, what is CAAD doing, where is it being referenced, they can figure it out, you know, through process elimination. Yes. Yep. So, any other questions? Oh yeah.
Do you ever test your obfuscated code against some of the obfuscating tools out there that's built into like
Yeah.
Dexter jar, DK code?
Yeah. So, especially with just like ProGuard or R8 enabled, they do a pretty good job. The more complex your application gets, the more references that can mean the same thing. So that's the only time that can kind of get messed up. But for the most part, those tools do a really good job of breaking it out to where you can actually see kind of all of that bytecode inside of it. And they'll actually turn it all the way back, trying to convert it to a class file that's more Java-like and see. So there are some pretty fancy tools that are out there. Yeah, but with DexGuard enabled, they do have some other nifty features that try to prevent that kind of thing. Yeah.
I mean, is this a Dex code runs in the Android system or it's going to be converted to the native?
So DexCode, once it's on the phone, it's actually then converted into machine code. So then has another level to go into like assembly and launch inside the VM. So Dalvik bytecode is actually just a more human readable, or I guess Dalvik bytecode in the form that we've been looking at it is actually Smalley, and so it's just a more human readable version of that. But on the device, it's just a bunch of gibberish, but it's converted into assembly language there, machine language. Any other questions? Right. So I do want to install this application real quick, so I want to show you the output from it. So kind of what I'm just going into now are some other really quick ProGuard features that you can add that can definitely raise the bar for those tools that can do the auto mapping and retrace essentially what your obfuscation was. So get that installed real quick. Okay, install. All right. Okay. So I did install the application. Let's get my logcats. All right.
What would you just do? You installed the application?
Yeah. So I installed the app. I'll launch it.
What is that Visor program?
Visor, it just basically, because I have a real device, so it kind of broadcasts it up there for you all to see. So I just kind of wanted you to see that the log messages are being output. Should be, yeah, there. So those are log messages that are going out. There's a reason I'm showing you this. All right. Let's hop back over here. So I'm going to look at flavor 2 now, and the ProGuard rules I'm applying for that one. Repackage classes. So this is pretty cool. It's not really going to do much for an attacker to still find your main method, but does add another layer. So again, going into our classes.dex, so you can kind of see how before things were sort of all tidied up nice and tight for us. We kind of had package names there, indicating, this is Android, Java, Android X. Well, this repackage, it just kind of flattens everything and puts it all into one. So it makes it a little bit harder to track things down. You can just see the amount of classes that are being generated here. And a lot of these are just, the Android library and framework itself is being packaged up. So obviously this isn't, my 5 lines of code. So that's that one. Flavor 3. So this is actually, I'm going to remove log statements using ProGuard. So this is actually a really nice feature, especially on your release version of your application. If you're logging out messages, like crash reports or whatever, this makes sure that that's all removed in your release version of your app. And I'm actually going to show this. So this is version 3. Aside from that, it's left repackaged classes, so the actual classes.txt is very similar. Alright, so it's installed. And so you saw before that we had these log messages being printed out. And here is nothing. So there's no log messages. So cool. Yeah.
I think I'm wrong about this, but I thought originally like that password that you enter to compile your code into an APK, they use that password and like as part of the obfuscation to make your code like different. It has nothing to do with it. You can just open up any APK and just see everything.
Yes. So I didn't actually enter any code for this, but the mapping file that is generated will be different every time. So I mean that's a nice feature.
Okay.
So if one version of your mapping file is leaked, that's not going to be true for every version of your application that's out there. But that doesn't lock anything down. I mean, anyone can open up any APK and see
What was
that
that
stuff.
key tool thing?
Keystone.
Keystone, yeah, that's it. What's that for?
Oh, yeah, so the signing the APK, that's more just to post it up on the Play Store so that Google knows that this is a unique application for this unique corporation or person.
I thought they used that password and then like encrypt it in some way. Okay. Yeah, so okay.
Yeah.
So if I'm downloading an app from Play Store, right, I'm getting the DEX code onto my,
Yeah, oh yeah, sorry, yeah.
and then it's installing to the native.
Yep. But especially on a rooted device, it's pretty arbitrary to pull off any APK that you have installed on your application. So that's how you would normally go about looking at the DEX code, is that you could essentially go onto your phone, find that install package, so find that APK, download it, and then throw it in Android Studio or the other tools that are out there. I just say Android Studio because it's pretty easy to get. But yeah, that's typically how you could go about reviewing any DEX code.
So when you check into the Play Store, you give them the DEX code.
Yep. Yeah, you actually give them the entire APK. You just say, here's my application. Yep.
The mapping files, right? You said they come default with ProGuard. Is it like numerous mapping files, and can I create my own custom mapping?
You can create a custom mapping. You can pass in a custom mapping file. There are not numerous. They're all included in that one.
Okay.
Yeah.
But it's the same across every time you purchase ProGuard.
No, so that mapping file, like the values inside of it, they will change. So
Okay.
Postman, like we saw earlier, it won't always be CAAD.
Right.
I'm not sure how they generate those,
Okay,
what's
so-
going to be what, but that's not always going to be the case.
Okay.
Yes?
When someone downloads the application to their phone, what interprets what ProGuard has done?
Sorry, what was that?
How does it get deobfuscated when it goes to run?
So that's a good question. So it doesn't necessarily need to be deobfuscated when it's run because
Because all those methods are just different names.
exactly right. So they didn't necessarily do anything in line to prevent like its own code from knowing what something is.
So they'll still run as is.
Exactly. Yep. But that leads into a good point because ProGuard R8 can add a lot of weird issues to your code because how things are accessed. So if you access something via reflection, for instance, ProGuard has a very hard time of knowing where that is or what's actually being called. So it can't, so if it obfuscates that, then it won't actually know what method or what class to look at. So that can break your app. And so that's where having keep rules, and I am going to demonstrate some of those. That's why you need keep rules in some instances. So for instance, just a really very quick example. So in the Android manifest file, you have your launch activity, and your launch activity where the young create or like the main method, those kind of methods, they cannot be obfuscated because the application has to have an entry point. So if you obfuscate that, then immediately ProGuard will crash your app. So you have to make sure that you're keeping that particular file. They're smart enough these days to realize like where your app entry point is, so you don't actually have to manually add that keep rule in there. It does figure it out in some of those default files that you provide. But any other questions?
I can't
Can
remember.
this be applied to, I mean, I don't see any reason why I couldn't, just a plain Java application?
Yep, it can. ProGuard, that's actually what it was built for. It was originally for just plain Java jar applications, and that's why it takes place at that the transforming stage on the class files, not on the dex file itself. So you can still go out. That's actually what I was trying to do for this presentation. Was we don't even mess with Android applications. We just kind of look at the Java, because that way we can all do a command line and have fun with it. But I couldn't do that.
So is the mapping file goes with the text file or not?
What was that?
The mapping file,
Yeah.
it'll be,
It doesn't. It's not packaged in your application. Or just make sure you don't package it. But no, it's not.
it's not packaged, how would the application know, so then explain.
So that's more for the developers. The mapping file is more for you to, so if you get crash reports or things like that, you will actually know, because the crash reports that you receive on things like Crashlytics, they will be obfuscated, so the mapping file can actually be loaded to something like Firebase so that your crash reports will automatically be de-obfuscated. You can know what's happening. So that's why you keep the mapping file around. And ProGuard also provides a tool called Retrace that you can add in the crash report and your mapping file, and it can be obfuscated for you. So that's why the mapping file, you never want it to leave your own spaces. You want to hold on to that. Yeah,
So when you upload it to the Play Store, the mapping file is automatically left behind?
it is, yes. But you can say, hey, I want this to go to Firebase. Like there are Gradle commands that you can add in there to make sure that your mapping file goes to Firebase, because that is a built-in feature that Google offers. So essentially, that way you can get those automatically deobfuscated crashes. So,
Did you say dead code was added to with ProGuard? Like they add dummy code in there or anything like that?
ProGuard does not.
ProGuard R8?
No. No, so these tools are primarily meant to make your app better and smaller and run faster. So that's why I said like the obfuscation to them is really just a way to further optimize the code, so it's not having to take in these giant class names or method names. They can just call a.e or whatever. So that's really the primary reason for obfuscation, but it's a nice feature that it does kind of make it harder to read for hackers. Yeah.
So how much security does this provide obfuscating the code? Is it like a lot, or is it like a thin lock?
Yeah, so that again is a very good question, because it doesn't, I wouldn't say to any efficient, or not really efficient, but any experienced hacker, it's going to add too much. It makes it harder. Like obviously, if they find an application that's not obfuscated, they're like, heck yeah, like I know exactly what's happening. But if it's obfuscated, they're like, gosh, now I gotta, whatever. But it's just going to be a time thing. It's not going to be like, yeah, you're never going to hack with this. It's more just delaying them, from being able to know everything about your application. Because if it's obfuscated, they can figure out portions of it, but they might not know the whole picture. Where if it's not obfuscated, it'll be pretty easy for them to kind of figure out the whole picture.
So my question's kind of along those lines too. So like, I've never developed an Android, but I've got a lot of other experiences.
Mhm.
One metaphor I could think of is like, if you do front-end development and you run your JavaScript through Webpack or whatever, and it adds all kinds of minification, obfuscation, all that stuff. That doesn't secure it, it just helps compress it, which makes it, smaller bundles over the wire and all that, optimizes basically.
Yep.
And, maybe it's a little bit of a pain for somebody, but it still doesn't, it's not like I should be throwing all my like AWS secrets in there because of that. So like, I guess along those lines then, like, so, someone in your position
Mhm.
where you're, a big bank, someone's gonna want to target you. Like,
Yeah.
they might skip over, my lame ass, because like, who cares? But like, if someone's trying to target you, this to me doesn't really secure you.
Yeah.
It just, if they're dedicated to try to get you because you're a big fish, they're just gonna keep trying and put all the resources it takes, even if it means going through all the obfuscation part of it.
No, exactly, and especially things like state actors with a lot of resources, they'd be able to crack anything like obfuscation relatively easy. And that's why you can't just rely on one tool to do the job for you. Like I can't just be like, guys, it's obfuscated, let's get out of here, we're good, you throw it to the wolves, we'll be all right. You have to have that layered approach. You have to have coding practices, making sure that we're not putting sensitive data or sensitive actions inside of the app itself. Like maybe that's handled on the back end inside of a secure enclave, that kind of thing. So you don't want your client code to be handling a lot of your sensitive actions for you.
So can I ask you just then?
Yeah, no,
like, it's outside the scope of this talk, but if you just point me to like something that says like, what's the thing that can get me to secure my code even beyond this? Or if not, simply just do all your stuff on your backend API and simply have your client be just a REST call.
So that's what I would, definitely on Android, Google has produced a decent tool, SafetyNet, which that can actually get the environment data where your app is playing. So that can tell you, hey, this guy's on a rooted device, or he's in a debugger in the emulator, or he's doing some kind of tampering to your code. They can actually check that and send you that report. So that's a good check to have. Any kind of root detection, that'll be a good indicator. Like, hey, that's not like having a root device doesn't automatically mean you're bad, but it might be another indicator of something fishy going on. But I would say for a lot of your sensitive things, definitely handle that, like that kind of authentication, or is this guy, should he be here? Handle that on the back end. You don't want to necessarily leave that all at the front end. So I would definitely say SafetyNet. ProGuard's a good start. It's just kind of having those different layers on top of there and just trying to do as many checks as you can.
And I imagine there are linters and things like that.
Yeah. So Android does come packaged with a pretty nice lint tool to help developers. You can customize some of your own like security lint rules specifically. Like don't let people use HTTP requests, they call them HTTPS, that kind of thing. So you can write your own for that. But yeah, it is definitely a layered approach, and especially with Android, they kind of pride themselves on being an open market. People can root their devices and do whatever they want. So it's just kind of how do we make an app that is secure as well. Yeah.
Is it possible to upload to the Play Store without being obfuscated?
Yes. Yeah. And there's a lot of apps that are not obfuscated. So I would definitely say like just at a minimum just apply Minify enabled, and let ProGuard do its thing. But yeah, you can definitely release an application without it being obfuscated. Yes.
Is this obfuscation, sorry, is it applied only to the Android devices, or can it be applied to Java or .NET or all those
So ProGuard
desktop apps?
ProGuard is specific to Android, or ProGuard RA specific to Android. iOS does have similar protection measures. They have IXGuard, which is ProGuard equivalent. And for web, I know that, like he was mentioning, there are some tools for that as well. But again, a lot of these are primarily for optimization. So you definitely have to do your research, and security isn't just like, let's punt this off to this tool to take care of. It is like an everyday developer has to make sure they're not doing insecure things inside the app.
So there are a lot of versions of Android there, right? Minimal ones to maximum power. How do you optimize your code so that it runs on all these versions? I mean, which layer you go? You go back to Java 1.6 or whatever it is?
That's definitely, let's say, probably, that's definitely a big question, probably outside of the scope of just security in general, but ProGuard, things like R8, ProGuard, they do try to do that. That's what the X thing is all about. That's what this optimization, shrinking, obfuscation, that's what all that is really about, is just getting an optimized version of your application. To build for, Android 1.0, you definitely have to take advantage of things like app bundles, I would say, because that will just, give that user exactly what they need for their device. It won't package in everything from your app, so I'll research app bundles for that. Yep.
Are your tools and your Gradle config identical if it's Kotlin?
Yeah. Yeah, because at the end of the day, Kotlin's compiled, well, at least in reference to
To what we're talking about.
the ProGuard already, yeah, so, because at the end of the day, that's all compiled down to Java bytecode. Or, yeah, so that's going to be the same to ProGuard receiving it. But again, so there are really nifty things, I didn't have time to really want to throw that in here, but like using things like companion objects, but not really taking advantage of the full functionality of companion objects, just using them like a static object, for instance, in Kotlin. Really, that like blows up your, because how it's referenced inside of the bytecode, that can blow up your that Dalvik bytecode a lot. So adding that annotation JVM static does help, but there's a lot of things going on. Like whenever you start looking at the bytecode, like what my little thing here that adds a lot of functionality to me as a developer converted into bytecode, like all of the code that is generated from that. It's a pretty fun exercise, and that's kind of what this course was about, to get you interested to maybe want to dive into this, show you the steps to dive into it, so you can kind of see what's happening under the hood there.
So,
Yeah.
now I've done a lot of Scala work, and in Scala, functional programming in general, it's all about immutability,
Yep.
among other things. So, like, is there any security value in terms of like not having setters and any kind of mutability? Just everything's in your constructor, or it's not there at all, that kind of stuff. Is there any value from a security perspective for that?
Yeah, I mean, immutable objects in general, they're going to be, they're not just sitting around in your code base. Like once that object is done, it's done what it needed to do. It's going to get picked up by the garbage collector. So that in general, if you're using that for sensitive items, that's going to be a better approach. Dan might have any experience with that, like as far as like immutability, adding security.
I think to your question, just from an obfuscation and optimization standpoint, there's really not that much of a difference. Because it's still under the hood referencing everything. If you look at Kotlin, you have a val, you have a var. Under the hood, that's referenced the same way. If you're dealing with that in Java, you can see that pretty readily and available, where it's just kind of being abstracted when you're using Kotlin. And it's the same way when you get under the hood, because it's just assigning it to a different register within the bytecode. So getters, setters, not really that big of a deal. But yeah, as Dustin's saying, specifically when you're dealing with mutable and immutable objects in memory, you start to get around. Think strings, right? Strings are immutable in Java. Well, what happens if you store a password in a string? When that gets garbage collected, that's still in memory. So that's one of those things where it's kind of important, and definitely think about how you're storing passwords, passwords. But this is the call out.
Yeah, I know we've probably already gone over an hour, but I just wanted to kind of show a couple more quick examples of what ProGuard does. And this is really, really fast. So honestly, I don't even really have to show you the bytecode or anything for this. But so allow access modification, especially if you're producing something that's not going to be a library, you can actually, this will help your optimization step and potentially also make your code a little bit more difficult to read. I can enlarge that for you. A little more difficult for an attacker to read, because this will actually allow R8 or ProGuard to kind of change up the, I'm trying to think of a good word for it.
Signature.
Yeah, the signature and the behavior of methods or functions that you're, so if you do have a private static variable that you only want to be referenced in this context, again, weigh the security precautions for this, but they can actually change that so that it's more accessible, and they can move it around to better optimize how it's being accessed or where it's being used. So, if it did need to originally go through 3 or 4 layers to get to, through different references, they can just, inline that somewhere else. And, so that's a pretty neat modification. Optimization passes. This essentially just tells ProGuard or R8 to go through your app multiple times. This is actually already included in the default ProGuard file that I have listed. So this ProGuard optimized Android, that's already in there for that. But again, that will actually help your code to run faster, because it's going to optimize all of that inlining. So it'll go through once, do what it can, and then just keeps going through it. And it'll actually give you a report of that. And overload aggressively, This will actually let you use, as long as the values return different things, it will rename things the same. So, A or ABC can now be multiple methods as long as they're all returning something different. So that's what overload aggressively does. So this is, with the default program R8, this is a way that you can kind of make it a little bit more difficult for an attacker. And another thing that I didn't really mention, primarily because it's hard for you all to see, but you can actually see, whenever you throw it into Android Studio, like the size of your application and how these different changes are impacting it. So for our first flavor where we didn't obfuscate or do anything, our app size was 816 kilobytes. With obfuscation applied, it was 778, and then with some of our other features, it's like 781 and 777. So you can actually see kind of how ProGuard or R8 are impacting your application, and what you're adding, what is it doing to your app. So the last one I wanted to really quickly show you, the ProGuard files 5. So this is, I have two things that I kind of wanted to highlight with this file. So there are keep rules. And I have another slide that I'm going to go over with like which keep rules you should use, which you shouldn't use. That'll be fast, because I know it's late. But print seeds, just like your mapping file, print seeds actually shows you what you're keeping. So that's really important, and that's actually printed out to the same place as your mapping file. At least I know it is with DexGuard. I'm not sure with ProGuard, because I actually have to specify it to print to this location. But the seeds file shows you, so if you're having a crash, and it's really weird, and it says like, access, or can't find this weird blob, and you go to your mapping file, you find that weird blob was Postman, and then I say, okay, well, I guess I need to keep Postman, my interface. This is actually how you would do that. This is that keep rule for that. So you would say keep, interface, common examples, test file. And what keep does is it makes sure that that interface or that class or whatever you pass it is not going to be obfuscated, optimized, or shrunk. So that's what that keep file, that keep does. And then if you go into Siege, you can actually see, if I look up Postman, you can actually see it being kept right there. And all these other things that are printed out are all the things that are ProGuard automatically keeps because it knows that your app will crash. And a lot of them are like resource related, as you can see, like the $, $sign. Okay. So I just kind of wanted to show in the classes text file that Postman was kept. So you can actually clearly see it there. All right. Now I'm going to hop back over to the slides. We only have a couple more. So this is the different keep rule options. So rarely should you ever just do -keep on anything because again, that doesn't obfuscate, doesn't shrink, doesn't optimize it. There's actually other rules. So you can do keep class members, so that'll still shrink, optimize, and obfuscate the class itself, but the members it will keep. And so there's all these other options besides just using keep. The keep is kind of like the easy button, that's why a lot of people use it. There are other options out there, just keep that in mind. And this is an awesome blog that actually kind of breaks these down for you as well. All right. I was trying to show Android compilations. There's a lot going on. So that's what that slide was. So yeah, this is kind of what we talked about, and a lot of these terms were mentioned. I just kind of wanted to bring it up. The only one I probably didn't talk about was AOT and JIT. That's ahead of time compilation and just in time compilation. It's basically what happens to the dog-fight code on the device. So we don't need to go into that.
I got a question.
Yes.
So AOT is crossed out on its own there. Has Google, or has Android done away with AOT?
They combine them.
Just on its own? Is it just AOT and JIT now?
So I think it's higher, yeah, that's actually a good point, because I think it's higher devices are using AOT and JIT, but I think for lower end devices, it's still just AOT. Yeah. So I guess I'll mention it really quickly. So ahead of time compilation, basically, whenever you install your app onto your device, how I mentioned that it turns that Dalvik bytecode into machine language. That's essentially what this is doing for you. So that way you have a little bit faster execution. We originally started with JIT, just-in-time compilation, on like original Android devices. So whenever you would install your app onto this device, it wouldn't do anything. Then whenever you launch it, that's whenever it would try to optimize and turn everything in bytecode. And so the impact was that it was, yeah, the APK size on the device was smaller, but it ran slower because it was trying to do all those transformations or translations, just in time. So while it was running ahead of time, is doing it when you install the application. So that way, it's going to take up a little bit more room on the device. But whenever you launch it, you have a little bit more better performance. And the combination there is, it's kind of like it's constantly refining itself as it's running, so it's getting better as it's running, essentially. So yeah, that's that. And I think that there's some references, whatever Jake Wharton puts out, essentially is that. Any questions? I know we asked a lot during.
Are the slides going to be somewhere?
Yeah, so I'll put them up on my GitHub, and I can put my GitHub link in the comments on that meetup. So I'll do that. Yes?
Can you go back to the Android Studio thing?
Yeah.
This is like if you drop the APK in here, right? And then you can see it?
Yep.
Everything on the left is just off. Well, it's kind of blurry.
I know it's really hard, and sorry, I couldn't zoom in.
App or app build?
Yeah, so this is actually just your APK. So whenever you build your APK, you just go into your build folder. Build, outputs, APK. And these are just all my different flavors of the app, so that's the
And
different.
on the right, the res, can you do a drop down on the res?
Yeah, I know this is really difficult for you to see.
So-
You should be able to go to view and presentation mode.
So my question is, like, is everything like, since apparently it's not encrypted or anything, so is everything res and like meta inf, just if there's an XML file, everything's readable?
So let me show you right now.
It's like human readable.
So here's your Android manifest. So they do try to strip some things out.
What about the meta inf? Yeah, it was weird. It reminds me of, like, on the server side, like we have this thing we have one called Radical, and they like
Yeah.
scan anything. And one of the scans we had was that like we had an XML file inside like a meta inf or res,
Mhm.
and because XMLs are human readable, like it was throwing flags with our security scan, and that XML file had like just configs and SQL select queries. And so it was just like, then that's a very big flag, because people can go and see the select query now.
Yeah.
Because it's XML readable, and it's human readable, it's just clear and plain.
Yeah, I guess it depends on what that database was doing, because on a rooted device, you can pretty much just dump whatever is in a database. But no, that is, yeah, I mean, again, I think it just points to Android's like openness and, I don't know. Yeah, there are definitely some things that you just have to be, as a developer, cautious of, what you're doing on the client side itself. Yeah, because hopefully, you're not storing anything super sensitive on the device.
I think it's important to recognize too, this isn't just an Android thing. I mean, this is
Yeah.
an everything thing. I mean, like when you're pushing something on the client side, that's your risk. So if you have something on the client side that exposes the security risk or vulnerability, I mean, it's already there, and a determined attacker is going to get it.
Yeah.
And yeah, thanks Dan for showing this presentation. Wish we would have had that. Yeah.
Question, so you obfuscate the actual Dalvik code, right? Does that actually obfuscate also the XARM instruction too? Like, can I still look at the actual ARM instruction and be able to look at it and then it's just somewhere and read it?
So the only,
Because I can still pull that, right? Correct?
yes, it's not going to really obfuscate any of the thing that's happening on the device. The instructions, I guess, as far as like what is being executed is
Right.
going to be obfuscated, but not necessarily, what is happening on that end. But Dan, do you have, that's
Yeah.
Right, I mean,
So actually, so part of the ahead of time compilation drops the dex file into a part, which is native, and I think it could be read as ARM if you dropped it into Future or IdaPro or something. And I mean, there is an element of obfuscation depending on how it's implemented, but ultimately at that level, it doesn't really matter. I mean, you're still going to see the libraries that are being used. You're still going to see the strings that are necessary to operate. Now, that said, I mean, if you're talking about a third-party library that's included, then you would have to use like DexGuard to encrypt that to drop it down under, because ProGuard only functions at the Dex level.
yeah, and I think the reason I don't harp too much on DexGuard is because one, that's not really available to everyone. It can be pretty pricey. So, but there are other tools to try to provide more protection. But again, at the end of the day, especially if you are looking at it at that level, at the ARM level, I mean, you're going to be able to see, because some of the things you can do is like encrypt the string. So yeah, whenever you're looking at the Dex file here, you're not going to be able to really know what it's doing. But if you're just tracing it through the stack, at some point they have to unencrypt that so it can be used. And so yeah, you'll see that kind of thing.
Are you going to Black Hat or DEFCON or something like
Not
that?
possible. Yeah, I'm more, I definitely need to go. I haven't been yet. It's on my list. Yeah. Any questions? Anyone?
I see the previous slide.
Yeah. You wanted to see like the references? Yeah, I could have listed probably 1,000 here. I just, I got pretty generic. I mean, Jake Wharton, he did an awesome series, and I shamelessly, ripped some of his stuff for this. He doesn't go as deep into like what ProGuard and things like that do, but he's more talking about R8, some of the optimizations, and he has a ton of blog posts on it that are really awesome if you're interested in that. And if you haven't heard of him, he's a pretty
Is this going to be posted to the meetup?
What was that?
Is this going to be posted to the meetup?
Yeah, I'm gonna post my GitHub link to all this, like all the files and the slide, and in the meetup comments. So if you're interested. Yeah.
Are you on Medium or anything like that?
I haven't written anything on Medium. I kind of wanted to turn this into a blog post, just to kind of be able to show, because there's not really a lot out there that shows the Dex file after you do things, like after you run ProGuard. There's not, I haven't really, and that's one thing that I liked about this, like making all this, because it's actually showing what's happening at those steps, and so I'm thinking about doing something like that.
Are you doing any other talks?
Yes, good question. So Android Summit next month, we're actually going to be, because I know this was towing the line about being hacker related, we are actually going to demonstrate how you can modify Dex, myself and Dan Lowe at Android Summit, how you can modify Dex maliciously, install it back on the device, pretend like you're that app, and harvest passwords, and do that kind of fun stuff. So that'll be it's called App Security: Why Build an App If I Can Steal Yours. So I'm on the lookout for that one.
Who runs an Android Summit?
What was that?
Who runs that Android Summit? What is that?
I know. So it's like a 2-day DC conference, and I think it's hosted by Capital One and run by Capital One.
It's a Capital One run event. It started about 3-4 years ago, and we've been getting audience ever since.
We're actually having a keynote speaker from Google.
Yeah,
Pretty
so
cool.
you guys have heard of chat, like audience people, or the Android people probably know. Kind of like the creator of Android. It's going to be the keynote.
We'll have Chet Haas and Don Felker. Okay, so just for reference, Chet Haas gave the keynote at Google I/O as well, and we'll give her keynote.
That's awesome. Yeah, so a lot of GDE is going to be there, Google Developer Experts. So it'll be a good time. So definitely look it up. Try to go.
When exactly to
What was that?
what time, when?
August 14th or 15th?
Yeah, it's androidsummit.org.
Yeah. And I am on Twitter. I'm not super active on social media. I'm trying to get better at that. But I will include it here. And another really good security reference, if you need it, is this guy down below. So if you have any security questions or anything like that, definitely feel free to hit him up. That's yours, right?
Yeah, that's,
Okay.
I think that's
Yeah,
it.
definitely feel free to hit us
Probably
up.
less active.
Uh-huh.
Probably less active on Twitter.
Yeah. Yeah, I hope you all learned something. How easy it is to break an Android. It's kind of a lesson.
Great, cool. Thank you very much, Dustin. Yeah, that was great. Okay, and thank you very much to everyone else for joining. Come back next. We'll have another meeting next month. We're still looking for speakers. We're trying to figure out a topic. So if you'd like to present something or know someone or want to hear about something, please let me know. Let's see, Capital One's hiring, so if you're interested, let me know. If you wouldn't mind, there's a sign-up sheet around here somewhere, so if you haven't signed up, please, it's in the back over there.
Back here,
And, and if you parked in the parking garage and need your ticket validated, also let me know. Otherwise, enjoy the rest of your day. Thank you.
Thank you. Thanks, I appreciate it.
Yeah, thank you for coming out.
Yeah.